Welcome to the AlphaList podcast. I am your host, Toby. AlphaList is a closed community with over 300 CTOs that share their knowledge and experience in a Slack space and at events. With this podcast, we want to give our members and interested parties insight into the thoughts and ideas of top CTOs. If you're interested in becoming a member of the community, visit alphalist.com to find out more on how to apply. This episode is kindly supported by Fastly, the biggest challenger in the CDN market. Fastly is pushing ahead the technical boundaries and is, from my perspective, the best solution on the market. Fastly is known as one of the key drivers of the Edge Cloud movement. In one of the next podcasts, I will talk to Tyler McMullen, Fastly CTO, about WebAssembly and the Edge. Well-known customers of Fastly are Shopify, the New York Times, Reddit, GitHub, and many, many more. If you want to try it all with first-class support, just go to fastly.com/alphalist. Welcome to the AlphaList podcast. Today I'm very proud to have Ahti Heinla on the other line. And our topic today is how to be successful in 3 complex areas at the same time: IoT, robotics, and AI. Ahti is the founder of Starship Technologies, a company that not too many of you might know. It's the company behind the little white delivery robots that you saw maybe on photos, maybe in a certain test district they're currently rolling. They raised $82 million from different VCs. And I just know them because they do a test in my home district. Ahti, maybe you could elaborate on that a bit more, how you came to that idea, and from my perspective, it's totally crazy.
Yeah. Thank you, Tobias, for inviting me here, and hello to everybody who is listening. My name is Ahti Heinla, and I'm a co-founder of Starship Technologies, and probably in the past I was probably best known as having been one of the founding engineers of Skype, and I've been also part of a number of other startups. Most of which you haven't heard of because they never got past to the stage where there's a couple of people and an idea and then people decide that okay, this is not going to work. So I've definitely done a bunch of experimentation in my life, trying various different things, and Starship is definitely I think the most complicated startup that I have worked on or started. And if you ask, how did Starship come along, then me and my Skype co-founder Janus Fries, we were sitting together and thinking we want to work together, and what are the big startups that we could do? What are the ideas that we could work on together? And obviously after Skype, if you are one of the founding team members of Skype and you think, okay, what is the next startup you want to do? Then one of the criteria is that you want to do something bigger than Skype. And we thought, okay, what can we do with robotics that is potentially bigger than Skype? That means it kind of needs to touch everybody's lives.
And why robotics?
Robotics, because we were thinking that this is something that is an area that's opening up for startups. It's complicated to do, but it's not as complicated as it was 20 years ago. And robotics was, we were not fixated on robotics. This was just one of the ideas that hey, maybe we could do something in robotics. And we started thinking that okay, what are the big ideas in robotics? And then we realized actually a lot of the robotics ideas are not big in terms of business. If you want robots that are touching everybody's lives, what could that be? There aren't actually all that many options, but delivery is one of them. Obviously, people are ordering more and more stuff online. Commerce is moving to e-commerce. There's more and more delivery out there. People want things, and the movement of things in the world could be automated. And that's what we set out to do.
Okay, and could you tell us a bit more about the nerdy you? Like, how did you get into engineering, and why did you get into engineering?
I started reading like some introductory like electronics books when I was, I think, 8 years old or something like that. I was definitely interested in that area, and during my teenage years also tried out some things in electronics, but then. Looking back, I think I was very very amateurish in electronics, but my parents were both computer programmers. So my mother taught me how to program computers when I was 10 years old. I mean, she just came home at one day and just said, Ahti, I'm going to teach you something new. It's just like parents teach their children things, right? And in a couple of days, she taught me how to write a computer program. And we didn't have a computer at home. This was 1982, but we went to my mother's workplace and used these sort of big, copper-size computers to run my program, and it worked. And that was a great experience. And when I said that, in my teenage years, I was pretty amateurish as an electronics engineer or electronics hobbyist. Then in software, I think I got quickly a little bit better than amateurish level.
Okay, and what was it like? What language was it back then?
My mother taught me Pascal, and I later also learned BASIC, and then C, and then C++, and then much later I learned Python and SQL and right now if I am writing code, it's mostly C++, Python, or SQL. I don't write code every day nowadays, but at least every week I'm sure I do.
Okay, and how big is your company these days in terms of employees?
A couple of hundred people. So Starship has grown in about 6 years from two guys and a napkin and the whiteboard to a couple of hundred people.
And you're the CEO and you're still coding?
I'm the CTO and still coding. I used to be the CEO for the first 4 years, but then we hired next buyer from Airbnb top management as the professional CEO, because I actually never wanted to be a CEO, and I always wanted to be a CTO, and running the whole business. I didn't really think that that's my cup of tea, but I can run the technology part of it.
Okay, and how is it in Estonia? Are there like a lot of Skype people working in your company now, or?
In the beginning, there were. In the beginning, I think the first 20 people I hired in Starship, the vast majority of them were engineers, and I think most of them were ex-Skype. I hired from my own network. I didn't put up any ads or anything like that. I didn't use recruiters even. I just hired from my own network, and some of the top people that worked at Skype in the past together with me. But nowadays it's a little bit more diverse. It's also I said in the past I was known as founding engineer of Skype, but that was actually 18 years ago, right? So lots of stuff has happened, since then, and nowadays it's not that most of the people we hire in Starship, are just walking over from Skype. They're actually walking over from other places.
Okay, but I can imagine that it's kind of a very attractive thing for engineers to do these days. What you do there, right?
Absolutely. I mean, as an engineer, what is the coolest thing you can build? It's robots. Well, maybe spaceships is maybe another thing. But if you think as an engineer that what do you want to work on in your life, then autonomous driving robots that everybody's using, that's pretty high on the list.
Okay, so I had the idea for this podcast and to get in touch with you around 2 months ago when I stopped one of your little robots together with my daughter. She's 3 years old, and we stood in front of it for 5 minutes, and then it very loudly asked us to step away, and she was really afraid of it then, but it's on her mind still.
I immediately thought, so how does this thing work? What is under the hood? Was it like a manual intervention back then? What happened back then? Like, can you still see the pictures and recall the pictures of us standing in front of the robot somewhere?
I can guess what happened. If it was 5 minutes, then it was probably a human operator, because we also have an automated system that decides that, okay, now's the time that the robot should say that hey, I'm a delivery robot, can you please step away or something like that. But the automated system would be faster than 5 minutes. If you had to wait 5 minutes, then it's probably that actually the human operator was pulled in by the automated driving system, and the human operator decided that, okay, these people seem to be just fooling around in front of the robot and just obstructing the way on purpose, and then the human operator can essentially press a button to play essentially a number of different messages.
And what did the robot actually see, and what kind of sensors it is equipped with? Did it recognize that there are two human standing in front of it and holding it back, or what does the model detect?
Definitely, the robot uses its cameras to detect whether they're detect stuff like people, cars. Also things like mobility devices, wheelchairs, skateboards, various objects, bicycles, motorcycles. These things are all these sorts of objects are all in our object classification system. Plus, also it detects things like sidewalk, vegetation, buildings, and things like that. And these are all necessary.
And is it all like hyper-local trained? So if I move the robot from Hamburg, Eimsbüttel to another city, would it work?
It would definitely work, but it needs maps. So we are building the system in a way that we are annotating the world also for the robot. We are telling the robot by maps that okay, here is the place you should drive. Here is the place you should not drive. But in terms of for example, neural network training for image classification, this is not actually hyper-local. This is not that, a pedestrian in Eimsbüttel looks, actually quite the same as a pedestrian in United States, for example. There's some small differences, but not all that many. We do some hyperlocal training as well, particularly when we are recognizing the tell apart, what is a sidewalk and what is a road. This is actually something that is actually a little bit dependent on the area. In United States, some of the road markings are yellow, whereas in Europe they're white, and so forth and so forth. And traffic lights are different. But we just make sure that in our training data for our neural networks, we have a variety of different data from different areas of the world.
Okay, and I think I saw it 12 months ago when everyone, or when always someone was walking by the robot. That was then the trainer, essentially, or
it wasn't really a trainer. It was if you saw somebody walking with the robot and sort of guarding the robot, then essentially it was a let's say a safety driver or a robot handler that walks with the robot and essentially carries a radio controlled emergency stop button in the pocket, so that they can actually stop the robot immediately if they want to. And I could draw a parallel with how the self-driving car development is done. As probably a lot of people know, a lot of the self-driving car companies, they have started driving around with their self-driving cars, lots of times with the car being autonomous control mode. But they have this safety driver inside, or sometimes two safety drivers inside that have the power to stop the robot or to stop the car and take over the control. And they measure how often that happens and so forth and so forth. And the overall plan there is that if it starts happening rarely enough, then they can actually remove this safety driver. They can actually say that the safety driver is not necessary anymore. And the vast majority of the self-driving car companies, they are not there yet. They're not yet at the place where they see that, okay, this is happening rarely enough that we can remove the safety driver. But in Starship, we reached that point in some neighborhoods in 2017. So from 2017 onwards, we have been driving around without the safety driver. Actually, I think Hamburg Eimsbüttel is probably one of the most densest areas, one of the most difficult areas for the robots to drive. There's just it's just, in the fairly dense part of the city. It's not in the outskirts of city or anything like that. And there, yes, I think it was until relatively recently we were still using the safety drivers, maybe until about a year ago or 2 years ago or something like that. But in a lot of other areas, we actually stopped using safety drivers many years ago, and we were the first company in the world to do that. We were the first company essentially to operate autonomous driving robots in public spaces without these safety drivers and having a production service at that level. So that was technologically a big milestone.
Also, in terms of regulations, I can imagine, or
yes, in terms of regulations, that also matters. I think we had discussions with also Hamburg City and they also, of course, are somewhat conservative and want to make sure that the safety situation is all right. And safety is, of course, a big thing in development of autonomous driving robots. And the initial testing we started in Eimsbüttel, we agreed with the city that we would always have a safety driver or robot handler with the robot, but this is no longer the case.
Cool. And what is under the hood then model-wise? I mean, you mentioned image classification. What else do you have to do to successfully drive through Hamburg Eimsbüttel?
There's actually a lot more than image classification. Image classification is one of these things that a lot of people have seen also the videos from Google and so forth of self-driving car companies that have this video that the car is driving and it recognizes all of these objects and so forth. Object recognition is actually, if I just think of how many people in Starship engineering work on that versus work on other things, then I would say the object recognition is visual object recognition is maybe 3% of Starship engineering. Maybe even 2% of Starship engineering. It's this place where everybody thinks that that's the gist of it. That's where things happen, but that's actually not necessarily true. There's a lot of other things also that need to come together to make an autonomous driving robot or also autonomous driving car, I would say, to really work.
I can imagine that a lot of time went into data preparation, right, and labeling, and really having that closed loop that works on its own, that is somehow fed by training data, and that is live and working. And that for me is really amazing. I mean, yes, image classification can be done easily with a Raspberry Pi and I think some ready-made models out there. But really having that closed loop is kind of the magic, right?
Exactly. Yes. So what we really need to have a robot autonomous driving in a safe way is yes, exactly this sort of loop that there's maybe image classification is maybe, let's say, one software component that we have, and on a comparable level, I'm just grossly simplifying, but let's say that there are 40 software components like that. And all of them, obviously, they need to have developers working on them. All of them need to have metrics that track their performance. All of them need to have this development loop or development cycle or iterations that, okay, I developed our new version, I put that live, I see how it's working, I gather data, I analyze that, I make further changes, then put it live, and the cycle sort of starts again. And the cycle essentially needs a data pipeline. There needs to be data pipeline and dashboards and alerts and so forth that analyze the data coming in. That okay, how did this component perform yesterday? And there would be an alert to a developer or developer checking a dashboard that all right, I need to change something here. And building all of that up definitely takes time. And it's much more than just taking this Raspberry Pi and the pre-trained model. We actually need to do all of this continuously, feed new data in it, realize that okay, actually this neural network we need to split into two. We also have this process always ongoing that if you first need to do some sort of software component, deciding for example that now I see, for example, that there are some pedestrians standing on the sidewalk and intentionally blocking the robot, just like you and your child did. Like initially, you wouldn't actually start immediately training a neural network for it. You would look for simpler ways. So you first look for simpler ways, then you advance this to a more complicated level, then to a more complicated level, all in the name of essentially getting better recall and better precision. Over time, and with 40 or 100 different software components, this takes years.
Are you building the whole stack on your own, or is there some software that you just license?
We are building practically everything on our own, and one of the reasons there being that we started this in 2014, so there wasn't a lot of that available, and with robotics, it's also that we realized immediately that we need to do a lot of vertical integration. We decided that we are going to build our own hardware. We're going to design our own hardware. We're going to select ourselves what sensors are we going to use, and build the software to work with these sensors. We were definitely looking at some existing robotics platforms we could use. We thought, okay, ideally we wouldn't build the hardware. Ideally we would use existing hardware. But we looked at what existing hardware there is. And we realized that we're going to waste a lot of it. The existing hardware is too heavy, too ugly, too expensive, has lots of sensors that we don't need, has wrong models of sensors. We realized we need to optimize this. We realized that almost all of the hardware components need to be just right for the sidewalk robot. That, for example, if you know that this is going to be pedestrian speed device, then it's almost certain that we need to have the drivetrain of the robot designed for that speed, for example, that it would reach good efficiency at that driving speed, for example, and there's no waste. And if you look at an existing robotics platform, a lot of them had top speeds, like 25 kilometers per hour, for example. We knew we don't need that. We knew that there's wastage there. That means the motors are too expensive for us, too heavy for us. And we wanted to build a lightweight robot and a low-cost robot. So these considerations led to our understanding that we need to design our own hardware. That also meant we need to match the software to the hardware. We decided that we are, at least at first, we are not going to use a LiDAR. That actually means that we can't use a localization system built on LiDAR. A lot of the autonomous robots localization systems are built on LiDAR. Obviously, we immediately then couldn't use that, and we set out to design our own localization system that wouldn't use LiDAR. So that worked, but it just also means that there's a lot of custom software.
So is it image recognition and GPS then, or?
We've been using lots of things, GPS, IMU, and so forth. But yes, the biggest part of our localization system is visual. We are identifying visual features in the environment, and we compare them to a pre-built map of the area. So we first drive through an area in fully manual control. That enables the robots, or actually the server software component, to build a map of the area. And then that map is essentially downlinked to all of the robots driving in this area, and then they can then localize against this map.
So the theory behind it is then if a human can do it with the eyes, then a robot should also be able to do it with the eyes?
Maybe in theory, yes. In practice, I think it's clearly still the case that for most tasks, a human is still better than a computer, except for some fairly specialized tasks for which you have to spend a lot of time to get to the same level as a human.
Yeah, I mean, your brain is also a bit faster than a Raspberry Pi usually, right?
Yes. Well, we're not really using Raspberry Pis, but yes, you're right.
And this podcast episode is kindly presented by MongoDB, the successor of the NoSQL movement. It's a very attractive, flexible and simple database system that can be integrated in no time. They have a developer-first approach and build a system that is fun to use and scale to terabytes or petabytes. You don't have to think too much about your database structure. Just start playing with it and develop it on the go. I tried their new cloud product called MongoDB Atlas, and all listeners of this podcast can easily do the same and test it in their favorite cloud, GCP, AWS or Azure. Custom-tailored deployment without over-provisioning, sandbox for developers, organized in microservices, and clear focus on developer fun and quality. To keep it simple, DevOps with more dev and less ops. Just go to cloud.mongodb.com and use the promo code podcast2020 to get started using their database as a service in the cloud.
And on the hardware level, what does that mean? Do you all build it in Estonia, or is that somewhere produced in China then after you built the initial model?
We are right now building our own hardware, so we are manufacturing it ourselves. But this is a little bit. The situation is a little bit more complicated. We are doing the final assembly ourselves, but a lot of the parts come from vendors who do sub assemblies for us. So we over time definitely don't want to be manufacturing everything in-house, but it's also a choice to make, like especially early on. If you manufacture million robots, then yes, definitely it makes sense to do it, perhaps in China. But the first robots you want to manufacture, you actually want the manufacturing to be close to your hardware designers, because the hardware is going to evolve quite quickly. So our hardware still evolves, and until now, I think it has been the right decision to do the final assembly ourselves. But in the future, who knows? It's a decision that we have to take at a really large scale. Definitely, it makes sense to shift to contract manufacturing, potentially somewhere far away from us.
And what does such a robot cost?
So it's a relatively low-cost robot. It's more expensive than your robotic vacuum cleaner, but it's much less expensive than a car.
I actually have a robotic vacuum cleaner from Xiaomi, the one that has been hacked and runs Ubuntu. Does your robot also run Ubuntu?
The robot does run Linux. That is true. But like I said, a lot of the software has been written by ourselves. It doesn't come with Ubuntu.
Did anyone ever try to hack it?
Definitely, we have done penetration testing ourselves and contracted companies to do that. I'm certainly not aware of any successfully hacking our robot in the wild.
Then if you look at all of the complexity that you have, which is a lot in terms of hardware and software, what is the secret sauce from your perspective of your business that is like the most valuable thing? Is it like the overall complexity, or is there one piece you would pick out and say that is really like huge value that we created there?
It's the overall complexity. It is a very complicated technology that we are building. It's a very complicated business that we are building, and that is actually a defensible competitive advantage against competitors. It's complex for us to do, but we have learned how to navigate with this complexity, and it's also complex for our competitors. We are still the world leader in this field after 6 years. So we founded 6 years ago, and we are still the world leader. We have always been the world leader in the field of autonomous delivery robots, and that just also shows that it's also hard for competitors. It's not that that there are tons of companies coming up and essentially showing that they can actually develop this really quickly. They actually can't. Where does this complexity come from? We are building the robot. We are building a consumer app. We are building a logistics optimization system that decides, where the robots should go, which robots should go where. We need to give accurate estimated times of arrival to the customer, and so forth and so forth. We need to maintain our robots. We need to make sure that when they break down, then they are fixed. We need to manufacture the spare parts. Lots of other things, and I've been just mentioning right now the technical parts. I haven't even mentioned all of the non-technical parts of the company.
Do you sometimes wake up at night and say, okay, this piece is maybe a bit too much, this complexity, I would like to drop it? Like, for example, you're building a B2C model and you have your own app, you need to do customer acquisition and so on. Isn't that like a bit too much at the end?
So the bigger part of the business you are building, the bigger value you are also capturing. So there is also business value in vertical integration. So I don't regret that, definitely. But your question is a very interesting one. That do I ever wake up and think that this is too much? And the answer is no. And that's actually quite crucial in that we realized also early on that we were building a really complicated thing, that there is actually a lot of potential obstacles to overcome. Like one thing, for example, that everybody told us initially that people are going to steal your robot. Okay, that's true. People can steal a robot. There's nothing physically preventing people from stealing the robot. But people can also, for example, there are delivery vans out there, right? They can actually go and puncture the tires of a delivery van. They can do that, right? How many times have you done it?
Not too many.
Exactly. I haven't done it either, But it's out there in the open. You can do that. It's very, very simple to do. People are not doing these things, right? It's possible, yes, but people are not really doing these things. And we learned that from early on when we did our first, real, drives in the wild without a safety driver or just observing the robot from far away. It's not the case that when the people see a robot and their first instinct is that, I want to steal this robot. No, it's not like that. They just walk past. They just look at, this is a robot, doing something. I don't know exactly what it is, but I'll just walk past. They're not disturbed by the robot. They just accept the robot on the sidewalk as it has always been there and it's performing a useful function.
Maybe for B2C adoption, you should build something in like a voice assistant, so you can interact with the robot. Because I see a lot of people walking by and really like they are interested. They want to somehow interact with the robot. They stop it and then like think about flattening the tires or anything. But should you build in something?
Absolutely, we have done quite little with the voice interaction so far, but could definitely do much more. But this is also the we have mentioned here the complexity. Of course, we want to also cut down on the complexity, or we want to not build things that we don't immediately need to build. It's complicated enough. But to answer your question, you said that essentially do I wake up and think that this is too complicated or this obstacle we can't overcome. We realized very early on that even though it's a really complicated thing to build, there are lots of obstacles. Then we can solve all of these things. We can get past all of the obstacles. If you think of every individual obstacle individually, you can solve that. So therefore, you can also solve the whole thing if you are persistent enough, if you realize that you shouldn't just get distracted by thinking that, how complicated this is, but you're just taking a step further every day. You're solving an obstacle every day. If you solve an obstacle every day, you will get there. Actually, you're making progress all the time. And that's what we have been doing.
If no one is introducing like a shorter path or coming up with a software that will solve it all, which isn't really realistic for the case you have. Did you ever think about building a platform for engineers so that you actually open up your model, so open up your robots and letting people write software for it?
We haven't considered that right now, but it's perhaps something we could do in the future. So far, we have done a lot of vertical integration and built custom hardware, custom software, and so forth and so forth. We're building it for ourselves. We're not building it right now to open up to other engineers.
If you ever do, I would buy one.
Well, if engineers want to play with our robots and want to make them better, they can also join our company. We actually have one of the engineers working with the robot control software is actually from Eimsbüttel.
Really?
He's living in Tallinn, Estonia, where our engineering is, and he moved from Eimsbüttel to Tallinn.
Is that the reason for Eimsbüttel, or?
That's not actually the reason for Eimsbüttel. We were operating in Eimsbüttel also before. We had good relations with the Hamburg city municipality, and they gave us the permission to test our robots in Hamburg a long time ago already. So that's why we have been operating in Hamburg.
Okay, interesting. But you could use it for employer branding, right? You could put some stickers on it. Join us if you're interested in building the new thing for AI.
we have been using the robots for customer acquisition. We have the stickers on the robot, telling that hey, you can order groceries and food with these robots. Download Starship app and off you go.
Maybe a display is the next step then. So one question which I found interesting. So in my career, I always found that it's really hard to establish successful collaboration between data scientists and engineers. Like the data science ivory tower is very attractive for engineers on one hand, and on the other hand, whoever sits in it can be like a bit complicated to work with in terms of I'm just doing the research work here. I can't do anything which can be used for production then, and it's really hard to estimate timings and so on. Is that something you managed to successfully overcome, or how does it work in your company?
It is indeed a recurring theme in our interviews when I interview candidates for our autonomous driving team, which has data science elements and production software writing elements. And generally, the most valuable employees, the biggest rock star engineers in Starship are the people who can do data science, can do machine learning, can write production software, and can build data pipelines, and not only can do all of these things, but are willing to do all of these things. That essentially whose motivation comes from that, hey, I want to make this robot work, and these are my skills, and I want to use all of these skills doing whatever it takes to get this thing working. And it could be that making the whole thing working, whole robot working, could be making one component working, but even developing one component requires pretty much all of these different skills. And there are people whose motivation is a bit different. Their motivation is that, oh, I want to build these really interesting machine learning models, for example. But how do I get the training data? I'm not the person to do that myself. I just want to work with great engineers who are building this data pipeline for me, and so forth and so forth. We can still hire these people, but they are not the rock stars in Starship because they can't just independently work on any problem and solve it. They need to be paired with somebody else. They need to discuss, with somebody else everything they do. So it's not so useful. But luckily, we do have a bunch of rock stars who really want to work on everything, have all of these different skills, and just want to make it work. And obviously, definitely is the case that there is actually a lot of pure software writing that needs to be done. It's not all that I just write 3 lines in with like PyTorch or something like that, and then the robot is built. It's not actually like that.
Okay, so it's about end-to-end responsibility at the end, right?
Exactly. The best rockstar engineers in Starship are the people who take this end-to-end responsibility and use all of their skills to make this happen.
One question that is still on my mind: what is the coolest thing that you've seen in AI in the last months? I mean, there are not too many things popping up. What is the coolest thing?
I would say in general how easy the machine learning part of it has become. That over something like 5 or 10 or 20 years, the deep learning has went from the point where it was not just a PhD topic, but it was bigger than that. It was like a major scientific breakthrough to get something working. So it was at that level, maybe 20 years ago, and now it's a level that you don't need a PhD to get some image classification developed. For example, you need just a senior software developer, for example, looking at it, for maybe learning it for a week or something like that, and they get the model trained and it works. It's a little bit more complicated in our robots because we need to also optimize the GPU resources, CPU resources, and so forth and so forth. But still, it's very easy compared to how it was about 20 years ago. But like I said, it's actually a relatively small part of our robot. The other parts are actually still the same. But it's amazing to see the progress in the machine learning and deep learning field.
So one last question, Ahti. I actually managed to steal one of your robots in Eimsbüttel, and I hacked it and found a little hidden feature. And it's the ability that you, I don't know, secretly engineered into it to travel back in time. And I now kindly asked it to bring us back to the old days at Skype when you were developing software for Steve Ballmer. And you now have the chance to whisper something, like one sentence into your young ears back then. What is it?
Really hard to say. I'm actually a person who is not. I'm not like planning my career that here I want to be there in 20 years time, and I actually do not have like many idols that I look up to that I want to copy. But one of the things in general is that when I was building Skype, I was a founding engineer. I was chief technical architect, but I didn't build the organization. I had very few people reporting to me. Most of the time in my most of my time in Skype, I had no people reporting to me. So I was overseeing the whole technical architecture. I designed the peer-to-peer network that Skype was using, and so forth and so forth. I wrote a lot of the early code that we were using, and so forth. But I wasn't an organization builder. Now at Starship, I built the organization, and I led the organization for the first 4 years. And it's a whole different experience. It definitely, the organization had a huge technical component. Obviously, we were building self-driving robots. We were building groundbreaking technology that nobody had done in the world before. But still, there was a lot of human parts to it. There was a lot of organizational parts of it. Lots of management parts of it that was new to me, and that I had much less experience with. So this was a whole new world of my career that I didn't realize that existed, and I didn't realize that it's so influential and so complicated.
And some like it, some don't, right?
Yes, I think there are some engineers and and architects that want to move into management, and some don't. For me, I've never really wanted to be a manager, but I looked at it from the standpoint that I'm a founder. And as a founder, you need to do everything you can to make the startup work, and you also need to lead the startup. In most cases, or in many cases. So I led my startup, even though I never really wanted to be a CEO. That wasn't my sort of career aspiration.
But you would have whispered then, look at it earlier, or look at management.
Maybe not look at it earlier, but it was something that I didn't understand as well, or I did not realize how big impact it has, and I did not realize how much I have to learn in this area. Well, because obviously it was a huge learning experience for me, founding a startup and leading it for 4 years up until it grew to hundreds of people.
I think it's really amazing what you did there. I mean, having all of that complexity and production is hardly seen these days, and most people don't know about your company, I guess. It's still really up and growing, and your best times are ahead. So really looking forward to see what you're up to and how it develops.
Thank you. I definitely think that the Starship, biggest days of Starship are still ahead. And then when you say that a lot of people don't know about Starship, actually a lot of people also do know, because in the areas where we operate, for example, our delivery service, like in the city of Milton Keynes in UK, for example, and a bunch of US college campuses, for example, our robots are essentially everywhere. You can't really, live there without noticing our robots essentially every day. And for example, the people in Milton Keynes in UK, it has been a reality for them for more than 2 years that they have been ordering their groceries using a robot. And 2 years ago, this was world's first. This was something that people were really. It was a new experience for them, and by now. But if you have been living with this for 2 years, it's been part of your life. It's like okay, do I move somewhere else out of this city where there's actually no robot delivery service? I mean, it's a change in your life, right?
Yeah, looking forward to see how it is in 5 years from now.
Exactly, it's definitely bigger. We are right now in the scaling phase where we are adding more cities, we are adding more places where we operate. Our technology is ready for scaling.
Thanks a lot, Ahti, for the podcast. Looking forward to meet you in person whenever I'm in Estonia, and maybe we do an update a year or two and see where you stand then, and how many people order through robots. If I personally do it, then let's see. Thanks a lot.
Thank you. Let's see how this goes.
See you soon. Bye.
See you.
Thanks again to our sponsors, Fastly and MongoDB. To learn more about the Fastly services and get first-class support, just visit fastly.com/alphalist. And to try the new cloud product of MongoDB called MongoDB Atlas, just go to cloud.mongodb.com and use the promo code podcast2020 to get started for free.